9 square root of x. So for this problem, we cannot use the power x 0.5 in C++ or x to the square of 0.5 in Python. We cannot use the built-in method to solve the problem. So yeah, we have to write a function to solve the problem. So the idea is that we're gonna calculate a square root of a number. So for example, if x equal to 4, and we need to find that number gonna be 2. Yeah. So how can we calculate that? If a number meets the condition of monotonic increasing, so for example 2, 3 is monotonic increasing, so square of 2, square of 3 is also monotonic increasing. So basically it is like that. So this means we can use the binary search to find the number. So for example, from the left side, we set a 0. For the right side, we're gonna set a 4. So the middle of 0 and 4, it's gonna be 0 plus 4 divided by 2, it's gonna be 2. And then we're gonna check this number. If this number equals, if the square root of this number equals to the x, we're gonna return this number, it is 2. But if it is smaller, for example, if the middle of them is 1, if it is smaller, we're gonna increase it. If it is bigger, for example, it is 3, we're gonna decrease it. So this is why we can use the binary search to solve the problem. Yeah. So for the second example, we have 0 and 8. So the middle of 0 plus 8 is going to be 4. The square of 4 is going to be 16. So 16 is more than 8. So this means our guess for this number is too big. We need to decrease it. So from this side, R powder going to be equal to 3, and the L powder going to still be 0. So from 0 to 3, definitely we can find that number. It's going to be 2. Yeah. So this is why we can use binary search to solve the problem. The difficulty of this problem is because this is Java, and we are giving the countries of x. It should be an integer. So we need to define the number as an integer. So I'm going to define L equal to 1 and the integer of R equal to x. So this is because I'm going to check if this value x equal to 0, so I'm going to return x immediately. Otherwise, we're going to cause problems. Yeah, because this is an integer number, but the square root of the number. So for example, the square root of the number going to be m. M can be a really big number. Maybe m equal to a very big number, maybe 10 to the power of 2 to the power of maybe 20. So the square root of this number is going to be 2 to the power of 40. So definitely it is not an integer anymore. It is a long integer number. So definitely it is not okay. So this is why we have to check the 0 case. Now we're going to set the left and right border. Left is going to be 1, right is going to be x. So while L less than or equal to R. So from here, we're going to calculate the integer m. So m gonna equal to, here we're going to use L plus R divided by 2. Then we're going to check if m, normally we're going to use m times m less than x. So this means the number is too small. We need to increase it. So L going to equal to m plus 1. But we cannot use m times m because this number can have the overflow problems. It can more than the integer. It can more than this number, 2 to the power 31 minus 1. So this is why we're going to use m less than x divided by m. This is the first case. So else if m more than x divided by m, this means this number is too big, so we need to decrease it. So then it's going to be m minus 1. So here m plus 1, here m minus 1. Else it means it's equal, so we're going to return m immediately. So for the final result, if the square root of 8 is 2.8, so we need to round it down to the nearest integer. It's going to be 2. So this is why finally we're going to return r instead of l, because r going to be m minus 1. M equal to 3 minus 1, it is 2, because we're going to round it down. So from here, we're going to return r. Now let me just run it to check if it works, and let's just submit it. Yeah, as you can see, it works and it's pretty fast, and the time complexity is the log of x, log 2 of x. So this is going to be the time complexity, because this is a binary search. Even the x is going to be a really big number, but log x is going to be like 31. We only need 31 times so we can get the final result. So this is a logarithmic algorithm to solve the problem, because it is a binary search. I think that's all about it. Thanks for watching. See you next time.